Hello everybody, welcome to A to Z Learning Hub. In previous class, I have told you about union and its properties. Today, I will tell you about some properties of intersection. Properties of intersection. First one is A intersection B is the subset of A. Its proof. Its proof is obvious because from definition we know X belongs to A intersection B implies and implied by X such that X belongs to A and X belongs to B. That means you see, this is your A and this is your B and this is your A intersection B. So it is clear that X belongs to A intersection B means X belongs to A and X belongs to B. So it is clear that A intersection B, this implies A intersection B is a part of A. This implies that A intersection B is the subset of A. This proof is very easy. Next come to your second property. If A is the subset of C and B is the subset of D, implies that A intersection C, A intersection B is the subset of C intersection D. Let prove, you say, let X belongs to A intersection B. This implies that X belongs to A and X belongs to B from definition. This implies that X belongs to C and X belongs to D because you see A is the subset of C and B is the subset of D. This implies that X belongs to C intersection D. So X belongs to A intersection B implies that X belongs to C intersection D. So it is clear that A intersection C is the subset A intersection B. A intersection B is the subset of C intersection D from definition of a subset. It is clear, it is obvious. If let X belongs to A intersection B, this implies that X belongs to A and X belongs to B. This implies that X belongs to C and X belongs to D. This implies that X belongs to C intersection D. So A intersection B is the subset of C intersection D. This is the second property. You know, if there is given subset, this part is the left hand side is the subset of a right hand side. You remember one thing very strictly, that you always give implied sign. That means this implies sign indicates that A left hand side is the subset of right hand side. Next, third part. Third proof is A is the subset of B and A is the subset of D implies that A is the subset of B intersection D. Let X belongs to A. Proof you see. This implies that X belongs to A and also X belongs to D because A is the subset of B and A is the subset of D. This implies that X belongs to B. Sorry. Let X belongs to A. You can write X belongs to B and X belongs to D. This implies that X belongs to B intersection D. So X belongs to A implies that X belongs to B intersection D. Hence, we can say A is the subset of B intersection D. B intersection D. Proved. Next come to your fourth property, union is idempotent. That is A intersection A is equal to A. Let X belongs to A intersection A. You see, when there is given implies sign, equal sign, left hand side is equal to right hand side, you give implies and implied by symbol. You remember this? This implies that X belongs to A and X belongs to A. This implies and implied by X belongs to A and X belongs to A. What does it mean? This implies that X belongs to A. So X belongs to A intersection A implies that X belongs to A. So A intersection A is the subset of A. This is the first part from top to bottom. Again from bottom to top, because it is given implies and implied sign. A is the subset of, A intersection A is the subset of A and A is the subset of A intersection A. This is the second part. From 1 and 2, it is clear A intersection A is equal to A. It means union intersection is idempotent. Intersection is idempotent, not union. Union is idempotent. I have already proved previously. This is intersection is idempotent. This is your fifth property. It is commutative. A intersection B is equal to B intersection A. Let X belongs to A intersection B implies and implied by X belongs to A and X belongs to B. From definition of intersection, this implies and implied by X belongs to B and X belongs to A. This implies and implied by X belongs to B intersection A. So A intersection B is the subset of B intersection A. This is the first part, and B intersection A is the subset of A intersection B. From 1 and 2, we can say A intersection B is equal to B intersection A. Similarly, this is your fifth proof. Next come to your, this is your fifth proof. Next come to your sixth proof. Union is intersection is associative, that the A intersection whole of B intersection C is equal to A intersection B whole is the intersection C. Let X belongs to A intersection B intersection C implies and implied by X belongs to A and X belongs to B intersection C. You remember one thing, you don't split B intersection C at a time. A intersection B, and for this intersection we give and then for B intersection C we write X belongs to B intersection. Implies and implied by X belongs to A and here you split X belongs to B and X belongs to C. Then implies and implied by X belongs to A and X belongs to B, because in right hand side these are in one bracket, so you keep it in one bracket, and X belongs to C. Implies and implied by X belongs to A intersection B and X belongs to C. This implies and implied by X belongs to A intersection B intersection C. So we can say A intersection B intersection C is the subset of A intersection B intersection C. This is the first from bottom to top. A intersection B intersection C is the subset of A intersection B intersection C. You remember this? From 1 and 2 we have A intersection B intersection C is equal to A intersection B intersection C. This proof is over. Next, another proof. This is your sixth proof. Sixth property proved. Next come to your seventh property. A intersection phi is equal to phi. Proof. Let x belongs to A intersection phi. This implies and implied by x belongs to A and x belongs to phi. X belongs to A and x belongs to phi, which is quite impossible. We can say x belongs to phi. If element is x and x belongs to phi, because phi has no element and x belongs to A, so it is quite impossible. You can write x belongs to phi. So A intersection phi is the subset of phi and phi is the subset of A intersection phi. From 1 and 2 we have A intersection phi is equal to phi. Next come to your another proof, that is your 8th property, A intersection E, that is the universal set, is equal to A. Suppose you see this is your E or U and this is your A. Let x belongs to A intersection E. This implies and implied by x belongs to A and x belongs to E. X belongs to A and x belongs to E means this part is common for both sets. This implies that x belongs to A and. So we can say A intersection E is the subset of A and A is the subset of A intersection E. From 1 and 2, A intersection E is equal to A. Next come to your and property, that the phi intersection phi is equal to phi. Empty intersection empty is equal to empty. It is obvious. Proof. These are the properties of a intersection. Next come to your distributive laws. There are two distributive laws. First one is union is distributive over intersection. That is A union B intersection C is equal to A union B intersection A union C. Second one is intersection is distributive over union. That is A intersection B union C is equal to A intersection B union A intersection C. First one is union is distributive over intersection. First proof. Let x belongs to A union B intersection C. Implies and implied by x belongs to A or x belongs to B intersection C. This is your definition of a union. Next come to your x belongs to A or x belongs to B and x belongs to C. This is your definition of a intersection. Next you see, you can write, very important step, x belongs to A or x belongs to B, you can write, and x belongs to A or x belongs to C. You remember this step? X belongs to A or x belongs to B and x belongs to C. We can write x belongs to A or x belongs to B and x belongs to A or x belongs to C. This implies and implied by x belongs to A union B and x belongs to A union C. Next step is x belongs to A union B intersection A union C. You get right hand side. So A intersection B union C, A union B intersection C is the subset of A union B intersection A union C. This is your first part, and A union B intersection A union C is the subset of A union B intersection C. This is your second part. So, A union B intersection C is equal to A union B intersection A union C. This proof is over. Next come to your intersection is distributive over union. How can do it? Let X belongs to A intersection B union C implied by X belongs to A and X belongs to B union C. This implies that X belongs to A and bracket, you give bracket, X belongs to B or X belongs to C. You can write, then you write X belongs to A and X belongs to B, or X belongs to A and X belongs to C. So you can write X belongs to A intersection B or X belongs to A intersection C. This implies that X belongs to A intersection B or union A intersection C. So left hand side is the subset of right hand side is the subset of left hand. So it is clear that left hand is equal to right hand. Second proof you do by yourself. Next come to your, this is your union and intersection. Let's come to your difference. Difference means you can give this sign or this sign also. Let, definition you see, let A and B are two non-empty sets, then their difference is written as A difference B or A minus B. You can write A minus B or a difference. It means the elements are present in A but not in B. So, mathematically X belongs to A difference B implied by X such that X belongs to A and X does not belong to B. X belongs to A and X does not belong to B. In Venn diagram you can write, suppose this is your universal set and this is your E, this is your A and this is your B, this is A and B, and this part is your A difference B. That means the elements are present in A but not in B. This is the A minus B, we can say A difference B. I am giving some example. Suppose A is equal to, example 1, suppose A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6. So you can say A difference B is equal to, from 1 to 3, 4, only 3, 4 is gone, are gone. So you can say this is 1, 2. Your example 2 is, suppose A is equal to 1, 2, 3 and B is equal to 4, 5, 6. Here A difference B is equal to, that means from 1 you subtract B, that means no elements are gone. So that is your 1, 2, 3. Another example is given, example 3, suppose A is equal to 1, 2, 3 and B is equal to 1, 2, 3, we can say A minus B, that means from A all the elements are gone, so that means A minus B is equal to 5. These are the examples of difference. Next come to some properties of a difference. First property is A minus B is not equal to B minus. You know A intersection B is equal to B intersection A. A union B is equal to B union A. But we show A difference B is not equal to B difference A. Suppose you see in Venn diagram, this is your Venn diagram, this is your A and this is your B. This part is called what? A minus B and this part is called B minus A. You see, this part is not equal to this part. proof. From left hand side you see, let x belongs to a minus b. This implies that from one side, if you give one side, then you give implies x belongs to a and x does not belong to b. This implies that x belongs to x does not belong to b. A means only x belongs to a. Then you come to right hand side. Let x belongs to b minus a. This implies that x belongs to b and x does not belong to a. From definition, this implies that x belongs to b. You see, x belongs to a and here x belongs to b. So left hand side is not equal to right hand side. So we can say a minus b is not equal to b minus a. Next come to your another property. This is the first property. A minus b is equal to b minus a. Let x belongs to a minus b. This implies that x belongs to a and x does not belong to b. This implies that x belongs to a. Similarly, let x belongs to b minus a, which implies that x belongs to b and x does not belong to a. This implies that x belongs to b. So here x belongs to a and x belongs to b. Since x are not present in same set, we can say a minus b is not equal to b minus a. Next come to your another property. This is your second property, that the a minus b is equal to a minus a intersection b. Proof you see. Let x belongs to a minus b. This implies and implied by, because equal signs are given, so we give this implies and implied by sign. X belongs to a and x does not belong to b. You see, x belongs to a and x does not belong to b. So this implies that x belongs to a and x does not belong to a intersection b. Since x belongs to a and x does not belong to b, so it is clear that x is inside a but it is not present in their intersection, because these are not present in b. This implies and implied by x belongs to a minus a intersection b. So a minus b is the subset of a minus a intersection b. This is your first part, and a minus a intersection b is the subset of a minus b. This is your second. From 1 and 2, it is clear that a minus b is equal to a minus a intersection b. This proof is over. These are the properties. Next come to your complement of a set. A is a set, it is a complement written as a dash or ac. It means elements are present in not a. You see, let A is a set and U is universal set. Then complement of A is A dash or AC. So A dash, it is defined as elements are present in U but not in A. You see, suppose this is your U and this is your A, and this part is called, it's a complement. This is your A dash or AC. So you can say x belongs to A dash implied and implied by x such that x belongs to U and x does not belong to A. You can write A dash is equal to U minus A. That means here the elements are present in U, universal set, and not present in A. The rest elements are A dash. So for example, suppose U is equal to, and A is equal to 3, 4, 5, 6. So A dash is equal to, you subtract this set from this set, we can write 1, 2, 7, 8, 9, 10. You remove these elements only, so you can get the rest set. This is the A dash is equal to 1, 2, 7, 8, 9 and 10. This is the complement. The complement means the elements are present in U but not in A. There are some property. First one is complement of A is equal to A. Second one is complement of A is A dash. Third one is A minus B is equal to A intersection B dash. Fourth one is U dash is equal to phi. And the fifth one is phi dash is equal to U. These are the property. After this property, complement will be over. Suppose you see, first proof, let X belongs to complement of a complement of A. This implied by X does not belong to complement of A. That means if elements are present in a complement of A, that means X does not belong to A complement of A. This implied by X belongs to A. If X does not belong to complement of A, so we can say X belongs to what? A. So X belongs to complement of A means X belongs to A. So complement of A is the subset of A, and A is the subset of complement of A. So from 1 and 2, we can say complement of A is equal to A. This is the first property. Similarly, we can prove second property. Second property, you can prove. Now, I will prove second property. How will you prove? Let X belongs to complement of A. This implies that X does not belong to complement of A. This implied by X belongs to what? Complement of A. So complement of A is the subset of A dash, and A dash is the subset of complement of A. So from 1 and 2, left hand side is equal to right hand side. And next come to your third part. Let X belongs to A minus B. This implied by X belongs to A and X does not belong to B. This implied by X belongs to A and X belongs to B dash. This implied by X belongs to A intersection B dash. So A minus B is the subset of A intersection B dash. This is the first. And A intersection B dash is the subset of A minus B. From 1 and 2, we can write A minus B is equal to A intersection B dash. This is your third property. Let X belongs to A minus B. This implies that X belongs to A and X does not belong to B. This implies that X belongs to A and X belongs to B dash. This implied by X belongs to A intersection B dash. So A minus B is the subset of this, and this is the subset of A minus B. So A minus B is equal to A intersection B dash. Next come to your fourth property, U dash is equal to phi. Let X belongs to U dash. This implied by X does not belong to U. So if X does not belong to U, that means X is in universal set. We can write X belongs to phi. Belongs to phi. So U dash is the subset of phi, and phi is the subset of U dash. From 1 and 2, we can write U dash is equal to phi. Next come to your another property, phi dash is equal to equal to U. Let X belongs to phi dash. This implied by X does not belong to phi. If X does not belong to phi, this implied by X belongs to U. If X is in a null set, then X must be in universal set. So phi dash is the subset of U, and U is the subset of phi dash. So we can say phi dash is equal to U. So in this class, I have told you about properties of intersection, difference and complements. In the next class, I will tell you about De Morgan's law and some other set properties. So, if you like my channel, please subscribe my channel and share my channel so that I will be motivated to give you more beautiful videos. For today, thank you.